Thank you. Thank you. Can you hear me okay? Yeah? Thank you again for having me here, and thank you to Stefan from Brainlab as well. I'm Rio Caraeff. I am Chief Content Officer at Magic Leap. And I thought I'll tell you a little bit about what we're doing, what we've shipped, where we're going, and some partnerships that we're very proud to share with you today. In the spirit of amplifying the human condition, right, and having fun, I thought I would start with a little video showing a collaboration that we worked on with the Weta workshop in New Zealand, which is a fun title that ships with every Magic Leap device. Let's turn the sound up if we can. There we go. Oh, there is sound, hopefully. Can you turn the sound up, please? No? Oh, well. There is sound. Well, anyway, I'll talk about it. So this is a project called Dr. Groordbort's Invaders, and it's a multi-year, Hollywood-style production. Everything you see here was shot on device, so it's all. There's no compositing there as well. Except for this part here. Invasion! So at Magic Leap, I think what's core to the company is that we're all about people, right? So at the end of the day, people who go to work, people who have families, people who need entertainment, people who need information, people who need to be productive. And so we don't focus myopically on one specific sales channel. You have to use words like consumer and enterprise. But at the end of the day, we're all people, right? And what we're trying to do is to make the world a better place through using technology to amplify the human condition. I like to talk about activating your superpowers, or your inner 10-year-old, making you feel like all of a sudden you have X-ray vision, you're smarter about the world, you can do more, you can connect more, you can be more entertained, you can be more productive. So these are all the core kind of attributes of who we are as a company. It doesn't. Sometimes you may say it means you're more consumer focused. It means you're focused on entertainment. But at the end of the day, we're all people. We all need these things. A little bit about the company. Founded in 2011. We're a very big startup now with about 1,600 employees, just under 3,000 patents, and a lot of investors that you see on the side there. We believe that spatial computing, where the digital world is seamlessly and persistently integrated with the physical world, is the next wave of computing. We think ultimately that's the case. There's a lot of words here, but I'll just talk through it. So spatial computing to us is about presence, right? It's about unimpeachably being present in your world. It's about persistence. It's about the digital world and the physical world coexisting in a persistent way, not ephemeral or temporary. It's about scale, right? It's about thinking about larger than life, municipal, city scale experiences. It's about, Tinkerbell landing in your hand, and then also what can you do with something larger than life? It's about awareness. It's about understanding the physical world, so that way you can stick the digital world into it with more purpose and meaning. Interactivity, it's not about consuming or watching. It's about interacting with and being a part of something. It's about respect, right? So it's about understanding. You know, I have to balance the cognitive load of people. I have to respect privacy, respect personal information. So it's about understanding that we're in charge, humans are in charge. It's not technology driving it, it's technology serving humanity. It's about sentience, right? It's about awareness as well. So these are all the core attributes for us. We've been at this for a little bit of time. 2014, this was a room size prototype. 2016, we were developing with a big wearable on the head. 2018, we shipped our Creators Edition in August of last year for software developers. So we have our Lightwear, our Light Pack, and our Control. And these are the core aspects of what drives us in all of our decision-making and investments. We call it our North Stars internally: sensory fields, live stream, human-centered AI, and the Magicverse. Sensory fields is really everything we do to make the experience real. So it's our investments in optics and light field displays. It's everything we do with haptics and touch. It's everything we do with 6 degrees of freedom controllers. It's the entire interface for the compute stack, the sensory stack, everything we do that makes the digital world interact with the physical world. Livestream is really about everything you do. Everything you do digitally and physically is your live stream. At Magic Leap, you control your live stream. You are in control of the data. You're in control of everything that accrues from your activities. You can choose what to do with it. Human-centered AI, this is how we approach machine learning at Magic Leap. So it's not AI, it's human-centered AI. So it's about amplifying the human condition. It's about empowering you. It's about giving you new capabilities. It's about people first. And then Magicverse. And Magicverse is really our term for, which I'll get into more detail here, about everything you do in spatial computing. It's the experiences you have. It's the fabric of connectivity between people across platforms. It's ultimately the layers that will sit across cities and spaces around us. So Magicverse layers, this is really what we call the layers of spatial computing, right? So you have the physical world, the base layer. You'll have the digital layer that sits on top of it. You can have transportation data, energy and water data, healthcare data, education, communications, entertainment, the concept of a digital twin, right, of something. So you'll have these nested layers of the digital world and the physical world that will coexist across platforms. So what we're working on at Magic Leap is about enabling that, right? And ultimately enabling it in a cross-platform and interoperable way. Not everybody is not going to have a Magic Leap device, and everybody's not going to have something else. It's going to be an interoperable world. You'll interact with through mobile AR. You'll interact through dedicated wearables and all kinds of things in between. So that's a little bit about who we are and what we're up to. I wanted to take a minute and introduce Stefan from Brainlab. Brainlab is our partner in healthcare and medical imaging, and then I'll come back and talk a little bit some more. Thank you.
Thank you, Rio. So now Brainlab has the exciting opportunity of bringing all that technology into surgery. And this conference is about optimism and courage. And to explain why healthcare is probably one of the most exciting applications of technology in that space, here a little video.
Cancer, the emperor of all maladies. It is a frightening disease for which currently there's no cure.
My oncologist suggested a brain scan because I hadn't had that tested. There were 3 tumors. And actually, I was prepared to die.
We are unquestionably in one of the most dynamic and exciting periods of medicine for cancer treatment.
We really have to think about what their quality of life is going to be, and quality of life starts with what's up here.
I no longer think about dying, I don't. And that's, I think, pretty dramatic.
And data has a tremendous opportunity to change healthcare. So when we talk about merging the artificial world with the real world, we need to first talk about how do we get a lot of digital data in medicine. And I want to talk about how that can be achieved in surgery. 30 years ago, when I started the company, that is what software in medicine really used to look like. And it has come a long way. The first task is to really consolidate and aggregate data from a number of different sources. So there's a lot of effort of sorting through the patient, loading that into systems, organizing data to represent the same anatomical situation, and then to put all that data in the same frame of reference to create a digital model of the patient. We need to first come up with something like Google of the patient's anatomy. We have developed a synthetic atlas that allows you to structure the data and label every single voxel in the different data sets accumulated from patients. So essentially now the patient's anatomy becomes machine readable. We can search across data for patients that will have the same shape and size of tumors, for example. Then we need consistently, patient after patient, make sure that we capture information in the same format, in the same detail. All the different anatomical structures in all detail. And we need to add other information, surgical pathways, fiber tracks, the telephone wires of the brain, for example. And Brainlab, as the name suggests, started in the brain, but we have now gone far beyond. Then, based on that, we're able to have a superior visualization of brain tumors, and we are able to really, with this anatomical mapping, peel away the different layers of anatomy, like the different layers of an onion, giving access to all the anatomical detail that may be available and accessible of a patient. So again, going back to the application of Magic Leap, this is all the heavy lifting and all the work that has to occur first to capture the patient in a digital manner so that we can essentially start merging that with the real world. And so the first, and that of course isn't like just limited to the brain, but also available in any other structure of the body. And then there's a number of different events. So a lot of times in a hospital or in surgery, patients are not just touched once. There's different types of procedures, different treatments that all have to be consolidated in the same data model. And that allows us to extract a lot of data all the way to even providing statistics, and that opens the door to big data analysis, even aggregation maps. So being able to mine the information that we can actually say what is normal or abnormal. How can we find for a patient with maybe Parkinson's disease, a small little atrophy of the thalamus? All this statistical analysis requires to actually being able to calibrate and measure the brain and the rest of the body to the same frame of reference. And that's what we do at Brainlab in over 4,000 hospitals around the world. And then there is navigation. So during a surgical procedure, we can track the position of a surgical instrument like a GPS system for the human brain. So that allows us to access a deep-seated critical structure such as a tumor in a more precise, less invasive way with less collateral damage to the structures around. And that same technology may be used to actually digitize how much of the tumor may you have taken out at a given point in time during surgery. We can use that to aim particular needles, screws, etc., down a predefined pathway. We can use the same technology to pick the perfect size and shape of a knee or hip implant. And we need to also capture where the patient is so that we can also take a radiation plan and capture the patient's position during the treatment to make sure that not only can we resect a tumor with a sub-millimeter accuracy, but we can also in radiotherapy hit a tumor with a radiation beam at the same precision. So these are all examples that are reality today, where we turn a analog treatment digital and merge the physical world with the anatomy of the patient that has been captured through some diagnostic examinations. And then there's additional information that is captured during surgery. During a surgical procedures, people use ultrasound, they use additional computer tomography. All those different data sources are all integrated and captured for the same patient in the same coordinate frame. So there's more and more data that is being then generated over time, and we can use that data to also aim robotics to correlate a predefined pathway with the physical approach during surgery. So these are all examples of how digital technology is used in surgery today. Then in many operating rooms there is touchscreens today that serve as the gateway into the digital world that makes it easy for physicians to access our data, and this is already installed in over 1,000 operating rooms around the world and soon being 10,000. So Brainlab is at a just prime position to be the company that really allows surgeons to access the digital world in a better way. So what you see here is just old-fashioned touchscreens bolted to the wall, and we'll show how that is going to be used in the future very soon. This is the use of surgical microscopes that allow you to augment information, so we can overlay now those models that we've generated and derived with the methods that I just described and put them onto the picture of a surgical microscope. And here we can even see as we're changing the depth, so can we change the context and the information that may be relevant, and we can change the perspective onto what we see on those screens. Changing the perspective of what we see is what essentially and in essence Magic Leap provides. First of all, the screens that were just on the wall in the OR now become virtual. So and that is also giving better access to a lot of hospitals that would probably not be in a position to make massive investments and ripping out the entire operating room to then apply maybe our greatest latest technology. It's an example of how we with Magic Leap will disrupt our existing business and replace it through a virtual way to bring content in whatever way to the operating room. And you can almost blanket the entire room with information that may be specific to the particular surgeon. And then, of course, merging what you have seen in navigation that may be just displayed at a screen in the corner of the room is now going to be overlaid onto the patient. And this is a little video that explains how that may look like, which, by the way, is something we have on demo just down the staircase. So all of you are welcome to try out spinal surgery yourself, but don't worry, we're using a rubber patient, so there is no risk for you to do any damage. So, but really, as there is an explosion of data and information in the operating room, Brainlab offers a tool to really synchronize the virtual world with the real world, giving surgeons better information to make better decisions. And these are all examples of using additional screens wherever you want to use them. And with another side effect of this technology from Magic Leap is, in order to merge the real world with the virtual world, it measures every aspect of the physical world. So it digitizes all those different components in the OR, and doing that across thousands of surgeries and many rooms around the world will know exactly where the sterile tray is and where the different components are. So we can use that information to optimize surgery. In any given hospital, the operating room is the #1 value driver, but it's also the biggest efficiency leak. And our technology will allow to accumulate better statistical information about how surgery is done, but also that information may be used then to optimize the surgical workflow. And to know where you're at in the workflow, to know what information to inject at that point in time, we need to also digitize all the analog steps of surgery. So when you pick up a surgical instrument and put it down, the Magic Leap 1 will be able to recognize that object, and therefore we know exactly at which stage we are in the workflow in the OR. And then, of course, medicine is about collaboration. It's about science, exchange between a number of different scientists. When, as a surgeon, you go and learn a new procedure, then while you do your first own case, then you would really like to have some additional assistant, and you would like to rely on the help of your teacher. So that brings us to the importance of a virtual presence of other people, and that's another example where Magic Leap comes into play. And I want to turn back over to Rio to explain what's coming next to enable even greater things in healthcare.
Thank you, Stefan. Yeah, thank you. To share a few more things with you, I'll share a new update to Magic Leap that we just made available in an over-the-air update we call Avatar Chat. It's basically how you can communicate and collaborate and share across time and space using our product. The avatars can be personalized. They can also be captured using volumetric capture as well.
Hey, what's up, guys?
Hey, Kai, what's up? Oh, hey, Chef.
What's up, guys? Okay.
Awesome. Looks good.
All right, guys, signing out.
All right, see ya.
Yeah, so that's a new feature we just added to the platform a few weeks ago. And I also want to share a little bit about our approach to human-centered AI, which we shared publicly at our developer conference back in October. We announced the concept of an Aya, or essentially a companion, a spirit, or assistant, and how we view that playing a role in your digital future. Here we go. So again, I'll repeat it over and over again. At Magic Leap, our philosophy is about kind of amplifying the human condition, and it really starts with respecting and understanding kind of the human mind. It's not about machines and AI, it's about amplifying kind of who we are with the addition of artificial intelligence. So again, it starts with you, the user, and a digital representation that's linked to your life. The concept of an Aya, or an intelligent companion, or a spirit. These are things that anybody will be able to make, right? I'm going to show you one that we're making, but it's not limited to the one that we're making. Anybody will be able to create an Aya. And then there's the environment, which is the physical environment that surrounds you, it's really so important to making it all work together. So we announced Micah, which is essentially our first virtual assistant and Aya in the human-centered AI of Magic Leap. Again, really about making the digital world and the physical world seamlessly go together. Mica was created in our Los Angeles office of Magic Leap. And you can see the attention to detail in terms of the facial structure, the skeleton, the muscles, the skin tone, right? So all of this is what you would experience on the platform as well. It's pretty amazing. So again, eye contact, sitting on a chair, walking it through the room, interacting, with art on your wall. These are all parts of how we envision this working together. But really about the seamless integration of the digital world and the physical world and the neural net and AI that makes it happen. Thank you.
Yeah. So
yes.
I think a digital assistant is also important. There have been several studies by different consulting groups talking about how rescheduling appointments, putting something in the surgical record, etc., will be a key component for reaping efficiency gains. Again, the healthcare system is highly inefficient, and there needs to be multiple different formats to really optimize that. And so, from Avatar Chat to Mica, these are all key components. And I would say healthcare is probably one of the areas where all the key ideas behind Magic Leap will be something will be implemented, and we're excited to then bring that to markets and to hospitals near you.
And as Stefan said, downstairs we're demonstrating all of the Brainlab experiences on Magic Leap hardware, and also have some other Magic Leap apps to share as well. Thank you.